everyone. Today we are here to solve this LeetCode problem number 129, some root to leaf numbers. So we have been given the root of a binary tree containing digits from 0 to 9 only. Okay, and each root to leaf path in the tree represents a number. Okay, for example, the root to leaf path 1 to 3 represents the number 123. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. Yeah, we know that. So in this case, we have a path from root to leaf that is 1 to 2, and this will be represented as 12, and then we have another path that is 1 to 3, and that will be represented as 13. So the sum of these two paths will be 25. And if you look at the second example, we have 495, 491, 40. So this is 495, 491, 491, and 40. So the total will be 1026. Let's look at the constraints as well. So we have nodes ranging from 1 to 1000. Okay. Since it's asking for root to leaf path, so we need the path from root to leaf. So I think we can use depth first search for this, and as soon as we encounter uh, this leaf node, we calculate the path, and if we encounter null node, then we don't do anything and return a 0. So what we can do is we can define a traverse function and then start working on it. So what we have to do is we let's simply return this, and this we have to pass a root node. So this will have a node, and then we need to keep track of the path. So it will be path val, and also we have to keep track of total val, so that will be total val. So the base case, let's try to think of the base cases. Base case is when we find a null node. So suppose this 0, let's look at a different example. Suppose we have like this, uh, we let's look at the example 1 for simplicity. So we have one, uh, and that has two children, left and right, having value 2 and 3. So when we reach the leaf node, what we have to do is we have to calculate the path value, and yep, that's we have to return the path value. Okay, so if how do we know it's a leaf node? Its left will be null and its right will be null. So that is a leaf node, and here we will return the path value. Otherwise, what we have to do is whenever we visit a node, we have to add its value to the sum. And another thing that we can do is we can check if the value exists for this node. So if it's not null, if it's null, then we return 0 and do nothing. So that's that. And then when we have added the value, so we were here and we added its value, and it's it has left and right. So what we have to do is we have to visit left and we have to visit right. So what we will do is we will do traverse node dot left path val total val and node dot right. Do the same thing on the right side. Let's call it left val and let's call it right val. And what we have to do is we have to sum all the paths. So we will do total val equals to left val plus right val, and then we can simply return this total val. Okay, and we have to pass path val initially as 0 and total val 0 as well. Okay, so uh, node dot left, node dot right, path val. I think it looks good to me. So what it will do is, let's try to dry run for this example. It will call this some numbers with root node 4, and then um, it will come in here. So root will be 4, and then it checks it's not null, so moves forward. So path val will become 4, adding its value. Okay, and then we check if it's null or not. Oh, I missed something. When we move forward, we have to not directly add, but we have to add it like this. Since it's we will be making it 12, so we will have to multiply it by 10 and then add it the next number. So this will be 0 multiplied by 10 plus 4, that is 4. And then we check if it's a leaf node. It's not. Then we call for left side of the tree, so it goes here. In this case it will go to 9, and then 9 will call again, so it will call 9 with 4, and then check if it's null node. It's not, so it adds the value. So path val will become 4 multiplied by 10, and this is 9, so this will be 9, and this will become 49, and then it will come here again and it will call for 5. Okay, so it will call for 5, and this will be 49. Now it checks it's null. No, it's not null, so it adds its value, so it will be 49 multiplied by 10, that is 490, plus 5, so that is 495. And now it will check if the left and right are null. Since these are null, so it will return path val as 495. So this left val will be returned as 495, and then it will call for the second path. So it will call for, earlier it called for 5, now it will call for 9, for 1. So it will call for 1, and then it will simply do this, and it will become 491, and it will take the sum and return. So now this traverse left here, it is 495, 491. Now we have traversed all of this, so now it will go to the right side of this 4. So it will be uh, this 490040, and it will call for this. So this will be 4 multiplied by 10 plus 0, that is 40. So now it will add these. These two were added earlier. Now it will add this and then return total value. Okay, let's try to run. To work, let's try to submit. Okay, it worked. Thank you. That's all for today. It was depth first search tree, binary tree. Thanks. Bye bye.